Okay, next section is namespaces. Just namespaces is a technique in C++ to allow you to group logically related sets of variables and functions, and that's what we're going to talk about now. So let's talk about the introduction to namespaces. What are namespaces? Why would you need namespaces? Defining namespaces. So I'd like to create a namespace. How do I do it? And afterwards, how do you use a namespace? So basically, the namespaces are it's like a directory structure, a hierarchical directory structure, which will allow you to partition application into, let's say, subsystems. So the each subsystem has its own classes, variables, and so on. The only problem is each subsystem can be developed by different developers. So different developers may use the same names for functions. So you can imagine the developer who has a print function, and normally in C, there's no excuse me, no namespace. Everything's just global. So you can have only one global print function. I think the same is similar for languages like MATLAB. So what we want to do is to avoid named collisions between different groups of developers. So let me just draw a diagram here before we start on to the details. So I've got let me draw a puppet for the developer. So I've got one environment. It's a big developer. Okay. So each developer is developing code here, and functions and classes and so on. And similarly for another developer here. The only problem is, well, first of all, the developers in the beginning have no contact with each other, and when you integrate each subsystem, you don't want to get named collisions. So as I've said before, one developer might have a print function here, and the other guy would have a print function. So which one would you use? Without using namespaces, it's going to be very difficult. So the basic objective is to define namespaces. Within a namespace, you've got your own functions, and later on you can explicitly say which namespaces you're using. So it's fairly clear that it's important to have namespaces. Otherwise, you're just getting one big amorphous flat environment, like it was with C basically. In the old days, we would have print functions with qualifiers like print underscore John and Mary and whatever, print 001, which is just terrible. What you want is like function overloading. You basically just want the same print function. So that's basically the motivation for namespaces. So namespaces correspond to subsystems. These are using namespaces are compile time options, so you can't change namespace at runtime as such. So it's not like class polymorphism in the moment. Okay. So why would I use namespaces? I've more or less given the reason. We want to avoid name clashes in the global scope. So C's got global scope, so if I got a global print function, there only can be one. And I've had some painful problems before. In the good old days of C++, the actual compiler, believe it or not, had a function called, I'm trying to draw it here, a function called test, because the compiler builder had forgotten to take out the test when it went into when the compiler was distributed. So I was giving a demo and I wrote a function called test, and the system didn't compile because the global namespace, the compiler builder had a test function and I had a test function, which is pretty stupid on the part of the compiler builder. Normally with the system functions, you have like a double underscore for your function names. Anyway, that's a bit of history, but it can happen if you don't use good namespaces. You're really going to get into problems. This is not part of the course, but basically when you're developing larger systems, you have to break your systems into subsystems in the analysis phase, just before we start programming. So the each subsystem could correspond to a namespace. And for the developers again, the developers, when they're building their own systems here, let me go back to my pen here. When each developer is developing his or her own functions, they do not have to be concerned with what the other people are doing until you get to system integration. So here's a very easy way. So let's say I want to create a namespace, and in the namespace I got data. First of all, you can put data into namespaces. You can also put functions into namespaces. So here's my first example using the keyword namespace, and every namespace has got a name. So in this particular name is called DataSim, which is the name of my company. In the scope of the namespace, which starts here and ends here, of course, I've got a double which is initialized immediately, and I've also got a function which just multiplies a value by 2. So that's my namespace. So that's a very simple example, and of course I can create a namespace in some file. So the how do I do it? So a namespace has to be done at file level. So you have to create a file, or multiple files actually, in which you put the components of your namespace and define your namespace as well. You cannot, for example, put a namespace into a class member data. It just doesn't work. So it has to be at the highest file level. Later on we can see that the namespaces can be nested. And if you've got a namespace with very many functions, very many data types and data, you don't necessarily have to put everything into one big file and one big namespace. So let me go back to my example here. So if I've got a huge namespace here with many functions, it's not mandatory to use the namespace starting here with the brackets and ending here with the brackets. I can split up into multiple files, but every time I still have to keep using the keyword namespace. So here, for example, we'll see in a moment some more examples. So we can have nested namespace, like a nested directory structure. So DataSim, the namespace has one double here variable initialized as well, but it's got an inner namespace, which is like a sub namespace, you might say, in which I've got a distance function, a distance variable. So it's DataSim slash inner, you might say, if you draw the analogy with a directory structure. Okay, so we talked about the splitting namespaces. I could have in some file, you don't see it here immediately, but the in some file I could have a namespace DataSim just defining the variables, so one part of the functionality of the namespace. I could have some sort of arbitrary function here in the same file, and the rest of the namespace in another file. So for example, the function func here in some other file. So you don't have to put everything into one big file. Another aspect is, we talked about header files and code files before. You could say I've got a file, a .hpp file, in which I define my variables and initialize possibly, and I define I declare my function here, but no body. But somewhere else I actually define the rest of the namespace. In other words, the body of the function func. And to this end, it's very similar to class notation. It's this is the so-called scope resolution operator. I say the function func in namespace DataSim. So that's where you put the body. So that could be quite useful, and it's in keeping with the design style guide, you might say. You put everything which is a declaration into a header file, and the code file could be somewhere else. Now, okay, so we now know how to define a namespace in one or multiple files using header files or CPP files, whatever. Now I want to use the functionality in the namespace in my program. So how do you do it? There are three options. The first one is called the using declaration. The second one is called the using directive, which is a high level global command, you might say. And the last one is explicit qualification. Explicit qualification means you actually tell explicitly in your code which namespace and which function you're using. The global namespace, just like the good old days, is still accessible using the scope resolution operator here without a namespace name, because it's got no name. Okay, so here's so I'm now going to go through the options here. The first one is called the using declaration. So I just say, what do you want to use? Well, I want to use something in the namespace. Well, you just use it. So I say, not everything in the namespace. So I'm saying, I'm very interested in func in namespace datasim. So I just say using datasim scope resolution operator func, and I just say print cout, using cout, the func evaluated at a certain value. So that's quite easy to use. So I'm using a using. It's sort of like a limited using. It doesn't necessarily mean I use all the other functions in the datasim namespace. I'm just using explicitly the func, not something else. So it's a bit safe in the sense that you are avoiding collisions with possibly other namespaces. The next option is like a global big bang option, you might say, using directive. The using directive allows us to use all the names in the namespace, all the variables, functions, without qualification. So you get everything. So here I'm using datasim namespace again. So it's a global directive using namespace datasim. You get everything. So if I say cout func, I get the same values before, but now I can print out my variable pi. Okay, so you get everything. It's maybe not what you want, but because somebody else may have a pi which is even more accurate. But this is what you get. It's a bit dangerous because it may collide. If you're using different namespaces, the namespaces may have their own functions and variables which have the same name, in which case you get a compiler error because it's ambiguous. Okay, the last option is the explicit access qualification. So I explicitly give my namespace and the corresponding function in the namespace without using any using whatsoever. So I'm just saying, here's an example. I just want to call func in my namespace without messing around with using stuff. I just say using, or say cout namespace double colon, and I give my function name. Okay, so these are the three versions. In most of my examples I use for std, which you've seen already, using the namespace standard template library. For the standard template library, I just using namespace std, and I just say cout, like I have here. It should be std. Some people advise using everything explicitly, like the example here of the explicit access. So every function, every namespace should be explicit. The only problem is it clutters up your code because you've got all this namespace junk floating around the place. And especially if the namespace names are very long, it's becoming awful unreadable, especially if you're working with templates, which we do quite a lot. So it can be quite tricky. I'll give you an example in a moment. Now, we talked about namespaces with long names, so we've got a way to create a shorthand notation. Oh, that's not bad. So we create an alias for a namespace identifier. So we have a very long name, let's say datasim.inner. Every time you have to say datasim scope inner, I just use an alias called DSI, and I just use DSI as before. Here's another alias, namespace DS is datasim, and I use explicit scoping, explicit access qualification, but not on the original namespace name, but on its alias. So it's quite easy as well. So that might be a good compromise, especially when you've got nested namespaces, which you do have in the Boost library, for example, or maybe large-scale applications, large-scale libraries. So that's a good option to have as well. Okay, so that was a relatively short section on namespaces. So what did we do? We showed you how to well, first of all, motivate what namespaces are, why you need namespaces. Basically, to manage logically related sets of software components without having name clashes in the function names, for example. So, large systems with very many classes, of course, and many developers as well. We want to be able to define a namespace to structure our life. Namespaces can also be nested. You can have sub namespaces, and using namespaces, there are 3 different ways to use namespace, which we've talked about. Later on, we'll be talking about how to actually simulate classes using namespaces. So we know what classes are. Let me give an example. Go back to my original namespace. Here we are. Here, for example, this is almost looking like a class, because classes are functions plus data. So here we've got a function, and here we've got data. In the function, we could have used pi as well. So it's like a simple class. And when we go to part 6, part 6 is applications. We will actually, when we're doing some option pricing, we will actually, instead of using a class in the initial stage, we'll create a namespace, and the namespace will contain my option pricing data and option pricing functions for prices and Greeks and deltas and sensitivities. So it's a quick and dirty way of getting your software up and running without having to create all the classes and all of this sort of stuff, which is extra work, of course. When you get everything up and running and the algorithms work properly, you can actually port or migrate your namespaces to classes. So it's pretty effective. Okay, that was the remark on concerning object-oriented programming. But of course, the big advantage is that it avoids name collisions. So you're grouping, you're logically relating all your software together. Now, namespaces are all over the place. STL, it's the STD namespace, of course. Boost has got lots of namespaces for each library. So, for example, the mathematical library, which I will show you in a moment, it's got the top level namespace is Boost itself, and one of its inner or sub namespaces is called Math, which is for the mathematical libraries. But if you work with Java and C#, it's all over the place namespaces. So it's important. A quiz. Let me go to before I do a quiz, let me go to an example. You don't have to worry about the example just at the moment. The contents of the example is to show you how we use it in Boost, for example. So Boost is the library we'll be talking about in part 5 of the course. So a little peep or a preview of what's to come, just a bit more, make it a bit more exciting. Okay, so here we are. I've got a test program. It's quite advanced actually. It's okay. Just let me give you the background. It's from the Boost Maths library. It's for a non-central chi-square distribution. So those of you who are doing statistics as part of your courses will know what's going on. So it's used for a number of option pricing models, like the interest rate models from Cox, Ingersoll and Ross, for example. But anyway, the main idea which I want to show here is I've lots of Boost libraries included here. Maths, you see here's Boost Math distributions, non-central chi-squared distributions, etc., etc. I've got my own directories here for matrices and the Excel output and so on. And I got a number of generic print functions, not so interesting or relevant just at the moment. Okay, so here's the message. I create some parameters which will be the input to my non-central chi-squared function. It's a template function here, you see, because it's been specialized to double. So I created degrees of freedom and lambda. So degrees of freedom and lambda parameters are defined here. But this particular function, which is a class actually, if I'm not mistaken, it's in the nested namespace boost math. So you have to, I'm using the explicit variation here. So I could have said using boost math and then just call the non-central function or object immediately. It's up to you. I'm using explicitly, so for didactical reasons. Here again, and I've got all these functions later on, that's not really relevant. Here's another example of boost Poisson distribution. I'm actually using the I'm using the explicit form here, you see. So I got all sorts of anyway, just to give you a little idea of what's going on. For the fun of it, just let me run it. So basically, what does this program do? Now that we're talking about it, we might as well finish it. What we're doing is, for a range of values of degrees of freedom and a range of values of your lambda parameter, he's creating a matrix, and the rows will be numbers corresponding to the different values of the degree of freedom, and the columns will correspond to the range of values corresponding to the lambda function. So he creates a matrix for its lookup tables, because the non-central chi-squared function is quite computationally intensive if you're doing it in runtime. So he creates a matrix beforehand, and you can access it using my matrix class. A nice part here is we actually we bring the data into Excel via the Excel mechanisms classes. We have the interaction with Excel from C++. So let me just, for the fun of it, run the program. So here's the output. You see, he's now created this matrix in memory. He's getting it into Excel now, which takes slightly more time because it's there's a COM wrapper. So here we are. So here's my output. Okay. So all thanks to Boost, and in combination with Boost namespaces. Let me close everything. Let me go back to my quizzes. So let's think about what we've talked about. Maybe you'll have to make a few namespaces before you can answer the question, but general question: how can we use namespaces to model data and functions instead of classes? And what would the advantages be? What would be the disadvantages of using namespaces? So it depends what you want, which can be an advantage or disadvantage. If you're only interested in results, quick, namespaces are fairly lightweight. What happens if you got two namespaces with the same function? So let me go back, and you want to use both namespaces in your code, maybe all the functions in the namespaces, whatever. Let me go back to my diagram here. Okay, so I've got let me draw my diagram again. So the question is the following: I've got namespace number 1 and I've got namespace number 2, and there's quite a bit of overlap as far as, let me draw a Venn diagram here. What I mean is the following: there's quite a bit of overlap between the two namespaces regarding the functionality, because both of them may have similar function names and functions and data. So then you got a problem. So the scenario is I'm using an application which uses both namespaces. So how to resolve ambiguities? One example in real life is the STL. Standard template library has a vector class, which we'll talk about later on. But Boost also has, in one of its libraries, also a vector class. So we've got a bit of an ambiguity. So how do you resolve the problem? You should be able to answer the question by thinking about the functionality of the syntax. Okay. So It depends what you want. Again, the last question: what are the relative advantages and disadvantages of using namespace directive, namespace declaration, and explicit qualification? In general, I can tell you, if there's a collision between two namespaces, you'll get a compiler error mostly, yeah? So that's not too bad. But it's got to do with readability and robustness and so on. So the question is, which option are you going to use in your code? There are different options. Okay, so we're finished now, and we'll take a break. Bye.